Okay, guys, so here's the second one. Um, Particle Q moves along the x-axis so that its velocity at any time t is given by this here, and its acceleration at any time t is given by that. The particle is at position x equals 2 at time t equals 0. Part A. In the interval 0 to 5, when is the velocity of particle Q increasing? Give a reason for your answer. Okay, so first of all, guys, I'm going to graph this in y1, and I'll write on my paper for myself, if I have to, use the y1 button for something. So that's going to be y1. I'll put this in y2 in the calculator. Here, guys, they're giving us an initial condition. They're telling us x of 0 is 2. Okay, so that's going to help us go backwards. Now let me write a derivative sequence. This is asking about q. Okay, so x sub q, v sub q, a sub q. Okay, this is a derivative sequence. Okay, when is the velocity of particle q increasing? Well, guys, velocity is going to be increasing when acceleration is positive. Okay, so they're asking you about f prime. All right, this is f, f prime, f double prime. So this is the first derivative of velocity. So you'd be looking for when that is positive. So let me graph both of those. Like I said I was gonna. 1 minus 3 cosine. Okay, and then this one. Okay, time interval from 0 to 5. So I go to my window. Let's see what that looks like. Okay. All right, so is it the red one or the blue one? And I don't really want to see both of them. So let me go to y equals. Okay, y1 was velocity. I'm looking at acceleration. Actually, we could use the velocity. Guys, you could do it two ways, actually. Okay, so let's do it using velocity. All right, so using velocity, they say give a reason. Oh, okay, never mind. So for giving a reason, we need to use acceleration. Okay, so let me, if I put the cursor over that and I hit enter, so now I'm just looking at the acceleration function. Okay. All right, guys, and I want to show you something. So we're looking for the interval where this graph is positive. So it looks like, I'm not sure if it goes below the x-axis here. It's kind of hard to tell. So let me try something. Let me go zoom box. Okay, and then, so this is going to help me do like a really tight window around this. And I'll just go below like that, because I don't even really need the negative part. Okay. All right, guys. Now, don't take this for granted, that this is all positive here. So let me go to the table, actually. If I go to the table, I could actually plug in a value. If I go second window for table set, and I put this on ask, and I'll go to this graph, or I'll go to the table. If I plug in like 0.1, oh shoot, that's a really small but positive number. So I don't know, there's other ways you could test. But anyway, 0, this graph here, what I'm trying to get at is that this graph is positive from 0. Okay, it never is going below the x-axis. From 0 all the way to that point there. Okay, so how do I find that point? I go second trace 0. Okay, and then I'm just like above it. Oh, enter. Okay. So the answer is from 0 to 3.963. Okay, so that would be the time interval. And they say, give a reason for your answer. Because on this interval, the acceleration is greater than 0. Okay, and that means that the velocity is increasing. Okay, so there's that. All right, so how many points? How many points? This is round 2. 2 points. Okay. So 1 point for the interval and then 1 point for the explanation. Okay. Find the position of particle Q at time t equals 3. So guys, we are needing to go backwards from velocity. Okay, so this we need the net change theorem. Okay, so x sub q of 3 is equal to, we need our initial condition, or I'll say initial value, plus net change. All right, we integrate the rate. Or maybe I should have, that's not great notation. All right, so what I should, all right, but this is what you want to know, okay? And then, so we've got x sub q of 3 is equal to x sub q of 0, they gave that to us, plus the integral from 0 to 3, and then in here I need the rate of this, which is velocity. So in here, v sub q of t dt. Okay, so this is, they already gave us that initial value, so 2 plus the integral from 0 to 3. Okay, and then I can do 2 plus math 9. 2 plus math 9. 0 to 3, and I'm plugging in velocity, that's y1. Okay, equals negative 1.490. Okay, that's the location of the particle on the x-axis. All right, so points, that was 3 points. Okay, so 1 point for the integral and 1 point for using the initial condition and 1 point for the answer. Okay, basically. All right, so there's that. Okay, so moving on. A second particle r moves along the x-axis so that its position at any time t is given by a differentiable function x sub r of t, where x sub r of 1 equals 4 and x sub r of 3 equals 8. Explain why there must be a time t on that interval at which the velocity of particle r is 2. Okay, so guys, you have to decide if this is going to be IVT or MVT. And you've got to know those theorems, because if you know those theorems, the intermediate value theorem and the mean value theorem, we need to know those. Then you could pick out the conclusion. This is asking us to explain why there must exist a certain time at which the velocity, so the derivative of this, would equal something. So that is the MVT. And we have to review these definitely in class. But this would be the MVT. Okay. So, guys, let me write it out like in table form. All right, and see if you like this. So we've got a table. So we've got two tables here. Or we can think of it. This is how I first taught it. So we've got this, all right, for this table. And what we want is to show that there's another table out there, okay, on the same time interval, okay, and it's not the same as this table. This is the derivative table. So I don't, the endpoints are no longer, or these y's are no longer that. I don't know what they are. What we're trying to show is that in the middle of this table, we've got a time t at which the velocity of the particle is 2. Well, guys, if this is the average rate of change from this table, then the mean value theorem allows us to conclude that yes, this is true. Okay, so let's see. All right, so do the slope. All right, so this is 2, this is 4, all right? So we've got delta y over delta t is 4 over 2 equals 2. Okay. All right, guys. Now this is how the mean value theorem goes. First, we have to be able to say, or actually, you know what? Okay. This is, all right, this is free response, so I think this would be good. All right, so we know differentiable. We have to say continuous as well. All right, we've got differentiability. We also have to say continuous. So we could just say this: since x sub r of t is differentiable, it is also continuous. Okay. All right, now let me do this. Therefore, one, or actually, you know what? Honestly, guys, this will get you full credit. Therefore, by the mean value theorem, and then literally just copy this. You just have to know which theorem that you're using, and you have to, like, any supporting work needs to be shown. Like I had to verify that the A rock over here, okay, A rock over here, and then I can conclude this. All right, since this is differentiable, it is also continuous. Therefore, by the mean value theorem, and then I just repeat this, there must exist a time t for 1 is less than t is less than 3, at which, and we could use notation, v sub r of t equals 2. Okay, so there it is, guys. So, okay. Now, or how much would that get? 2 points. Okay. So 2 points there. Okay, now this. So at time t equals 3, the velocity of particle r described in part C is -2. Okay. All right. Are particles Q and R moving toward each other or away from each other at time t equals 3? Explain your reasoning. Okay. So guys, we got to figure out their positions at this time and then also the direction in which they're moving. So at time t equals 3, the velocity of particle. Okay. So they're telling me that particle. So x sub r of 3 is equal to -2. No, v. Sorry, guys. V sub r of 3 is equal to -2. Okay, so I know that at t equals 3, particle r is moving left because that's negative. Okay. All right, so... All right, so maybe I'll just say that. So particle r moving left at t equals 3. And I gotta say why. Since v sub r of 3 is less than 0. Okay. Alrighty. Now, maybe now's a good time to get v sub q of 3. So v sub q of 3. Do I have it? V sub q. Okay, well, I could find it. All right. So v sub q of 3. So I'll find that now too. So v sub q, if I go back to the beginning of my problem, I have it labeled as y1. So that's v sub q. So I could actually go, we can get to it from the graph. All right, so that's y1, I believe. No, that's acceleration. Okay, so this is the velocity graph. Okay. And I want the function value. I want the y value on this at t equals 3. So you can get to it from here. You can go second, trace, and then if you hit value, and then I type 3, that's going to give me the y value. So 1.682. 1.682. Okay, that's positive. Okay, so particle Q moving right at t equals 3 because v sub q of 3 is greater than 0. Okay, so guys, I know they're moving in opposite directions, but yeah, so if they're moving toward each other, I would need, to know their relative positions. Okay, so now let me find their positions. Oh, actually, one of them I already know. I know that x sub q of 3 equals negative 1.490. Okay, that is from part B. And now I could actually do, x sub r of 3. Guys, they gave it to us. We already knew that up there. X sub r of 3 is 8. They gave that to us. Okay, so let me draw a little picture for myself. All right, so this is 8. This is negative 1.490. So those are the positions at t equals 3. And we've got Q moving right, okay? And then R is here and moving left. Okay. So the answer is, I'll say they are moving toward each other. They are moving toward each other because at t equals 3, I'll say Q is left of R and moving right, while R is right of Q, that's a little redundant, and moving left. Okay. All right, guys. So that is 2 points, actually. Okay, 2 points there. So 2 points here, and then also 2 points there. Okay.